just hit record. Am I recording? Yes, I am. Okay. Can I get a brave soul? Matt, I'm picking on you today to do all these answers right. Can you sub the numbers in here, please? Go ahead.
Okay, so M equals,
I can't hear. I'm sorry.
M equals 1 over A plus H.
Yeah.
Minus 1 over A.
Yeah.
Over H.
Okay. What I'm going to do, and this is the same, guys. We did this exact thing for homework probably 2 or 3 days ago, right? The exact question was given to you. Okay. And we did it up on the board too. All right. So can I get someone else who's brave to tell me what to do next, if anything? Oh goodness, Evan, go. Yeah, that's what I'm going to do in a sec. Yeah. Good. Okay. This is coming back for people a little bit, I hope. All right, next step is what? Smush, okay? So the smushing, and this is what gets people mixed up, that turns into A minus H all over A bracket A plus H times 1 over H. And it does actually make a difference, right? The negatives there, okay? It switches to a negative, so it goes through. So this turns into negative H over A bracket A plus H times 1 over H. So your slope is equal to negative 1 over A times A plus H. Okay, now this is what Matt had written, but then a moment of insight hit Matt. Matt, what did you realize once you saw that written there?
Well, H is equal to 0.
Why is H equal to 0? Good. But we'll say but because it's because a tangent means H equals 0. Your slope of this line is going to be negative 1 over A squared. I told you not to do that?
Yeah. Let's not follow that with the 0 and so next version.
No, hold on a sec. If I know, but you're doing something different though. If you follow this out, that's A squared plus AH, right? That's
Yeah, because H equals 0, then it gets canceled out. A times H.
Yeah, I know, but you didn't say you were subbing H in from 0 though. You just said you were following it out. That's what you said.
That was implied because that was
You didn't say it though, okay? I thought you just meant you want to write it as negative 1 over A squared plus AH. That's what I thought you meant. Sorry. Great, so that's your slope. That's wonderful. So if you go back to our list here, which is right here. Okay, great. We've got the slope of the tangent line. That's the slope of the tangent line. Okay, so let's go all the way back now to grade 9. I have my slope. In grade, don't roll your eyes. Grade 9 is fine. And in grade 9, you had things like slopes being like 2 and 3 and 1/2. In calculus, you have slopes like negative 1 over A squared. Okay, which is a little bit messier here. Can someone recall what the equation of a line is back from grade 9? Yeah, y equals m plus b is it. I'm going to use a different equation though. I'm going to use this equation that Mr. Lacey always used, which was m equals y2 minus y1 over x2 minus x1. So that we have y2 minus y1 equals mx2 minus x1. And actually, what he would write it as this actually. He wrote y minus y1 equals mx minus x1. So if you guys ever had him as a grade 9 teacher, that's the equation of a line that he would use there. Now the reason I want to use it like this, y equals mx, would work your way to it, take a little bit more algebra to get to where we wanted to go though. Okay. So what information do I know? Do I know anything? You know m. Anything else that I know?
You know what Y equals?
Good. And what else do you know? What x equals? Good. So we know here that our m is equal to negative 1 over A squared, right? X is, I'll say x1 is equal to A, and y1 is equal to, what was it, 1 over A? Okay, yeah, go ahead. Yeah, so what I just used, I used my equation for slope here, right? Okay down to here, right? So this is just like the slope equation, right? Like and then I rearranged it then, okay? So what I did is, think of this like, because the y and x are like fixed not fixed, but because they're variables in like an equation, you have an unknown y and an unknown x. If you take an unknown y and an unknown x and use any other point in your slope, you can get the equation of the line. Okay, right? So that's one way to do it. Another way I used to teach my 10 applieds, I used to do this one. And that works as well too, where m is your slope, p and q are your point, and that's the same equation as this. Some people also do it like this, and then you solve for your x point coordinate, your x point, your y coordinate, your slope, and you solve for b. That way you get your y-intercept. This is direct. This way that I do, I like for Mr. Lacey's way because it directly gives you the whole equation. Okay, so any other way, I'm just using the point slope equation. That's what I'm basically turning it into. So any one of those methods you may use. Okay, right back from grade 9. If you can't remember grade 9, that's fine. I can't remember grade 9. I took grade 9 a long time ago. I was in grade 7 actually when I did my grade 9 math. That's another story for another day. Okay, so let's sub some numbers in here. How are we doing for time? Good. So I'm going to sub things in as quickly as I can. Y minus 1 over a equals negative 1 over a squared x minus a. Okay, can someone be brave and distribute anything if they can? I don't like brackets. Joe, can you be brave, please, and distribute?
Okay, it's negative 1 over a squared x.
Oh, it's plus 1, okay, so plus 1, plus 1. Good. Can I ask away there, sorry? Yeah, go ahead.
Okay.
You good? You just cut this a little deeper, right? Like it's just letters instead of numbers. That's one difference. Okay, how do I isolate y now? Good. So because it turns to a plus, that's going to turn to 2 over a, which is nice. There's my equation of the line, which is beautiful. Doesn't that just make you happy? It should. Okay. So I need to get intercepts from here. Can someone, how do I get intercepts from an equation of a line like that? X equals 0 first. So that my y-intercept is instantly going to be 0 and 2 over a. Okay, so I think y equals mx plus b. That's to b. Have a question? What's that? Oh, okay. Originally, remember when we started here? Sorry, going all the way back to the first page here. Okay, so original point was just, I said a and b were just a point on the line. Because we were using 1 over x as our function, if x is going to be a, then y is going to be 1 over a. Right, so, and that's what sort of the foundation of the whole thing. No matter what we choose for our x value, everything's going to be based upon our starting x value, right? Every other calculation we use there is based on our starting x value. Now, if you think there's an asymptote of 0 anyway, right, for this, so that wouldn't work to begin with. Everything else would be fine. Okay, x-intercept. We're going to set y equals 0. So this turns into 0 equals negative 1 over a squared x plus 2 over a 1 over a squared x equals 2 over a x equals 2a squared over a x equals 2a. So I finally got my x-intercept and I finally got my y-intercept, which is good. I'm very happy about that. Why am I finally happy? I'm never happy because I'm a math teacher. But why am I theoretically happy? I have all the stuff that I need. How do I figure out the area of that triangle then? What's the area of the triangle? Right. So area is going to equal b times height over 2. Okay, what's the base gonna be? X-intercept, so the base is gonna be 2A. What's your height gonna be? Y-intercept, which is gonna be 2 over A. Which really changes to 4A over A over 2, which is 4 over 2, which is 2. And that is very awesome. Okay, if you don't mind me saying so. That took a lot of work to get to, okay, right? But what I'm hoping for you guys at, okay, is that if I give you the starting point and I say, okay, you got to find the slope of this, x-intercept, y-intercept, something like that, you should be able to do. Okay, the equation of this, to make the equation of a line from a tangent, you should be able to do. Okay, right? This one's a little tricky because there are variables in there, right? But as I'm saying, this is calculus, right? You have to stretch your brain. If I said x equals 1/3, you'd all say, yeah, no problem, I can do this easy. Okay, right? But when I say a and 1 over a, you guys get a little afraid. It's okay. Right? You guys can do this. Questions and fear. I see some blank looks from the back row and the side row and the middle row. Okay, it's okay to think. Thinking is good. This is what should happen in this class. Evan, you should be thinking. Yes, go ahead. Okay, what we were looking for. This is good. This is good. Good question. Don't escape here if the bell rings. I'll give you your homework still. What we were looking for to begin with, we wanted to prove that the area is going to equal 2. That's what we're looking to prove. Okay, that's what the original thing was. So we started for things that we needed, you know, and then went back to this, right? So there's the graph point, so the slope of the tangent, the x-intercept and the y-intercept will give us then our height and our base. And then we did all that stuff in the meantime. Okay? This is an awesome question. All right, homework for tonight is going to be page 20. Just so you're aware, in this class, because it's calculus, every night I'm going to assign question number 25 or, you know, whatever the most difficult question is in the book. Always. Okay, you'll always get the challenging questions in here. If you ask your older brothers and sisters or cousins that have been in my class before, all of them will hopefully say that they were ready for first university. Okay, I don't think anyone ever came back and said, yeah, I flunked out of first university, but I got a 90 in Mr. Sadler's class. Matt, maybe? No, Matt didn't have a 90 in my class. Matt didn't have a 90 in my class, okay? But, so, right, so you will be prepared after this, okay? So I will challenge you to this course. You will sweat a little bit of doing your homework every day, okay? That's okay. Calculus is hard. Okay, everyone's got that scribbled? 20 ABC, 2325?